All right, hey y'all, Mr. Kyle Myers Mathematics, and let's just jump into it. We're supposed to find the limit of each of the following sequences using L'Hopital's rule when appropriate. So number 28, n minus 1 quantity squared over n plus 1 quantity squared. So the limit of this is actually just going to be 1. I was going to go into like a whole thing, but it's 1. And the reason why is because they have the same degree. This is the whole, if you remember rational functions, finding the horizontal asymptote of a rational function, that's basically how you find the infinite limit as well. If the degree of the numerator, so numerator and denominator, if the degree of the numerator is less than the degree of the denominator, then you have a horizontal asymptote of y equals 0. If the numerator is equal to the denominator, then the horizontal asymptote is the leading coefficients divided. And if the numerator is greater than the denominator, then there is no horizontal asymptote. No horizontal asymptote. And sometimes they have you finding out the oblique asymptotes as well. There are oblique asymptotes that you could have for a rational function. But if we have a horizontal asymptote, then we have an infinite limit. So it's going to be going towards something as it goes to infinity. And we do. We have a horizontal asymptote, and that's going to be 1. Because if we were to expand these, it would be n squared minus 2n plus 1, n squared plus 2n plus 1. Now, nothing cancels here. It's really tempting because they're very, very similar terms, but nothing actually cancels. But the leading coefficients are 1. So 1 divided by 1 is 1. And so that's really it. That's all there is to it. And that would be an official answer because you could say, well, suppose it's the rational function, f of x equals, and then replace all your n's for x's. Then, according to the rules of finding the horizontal asymptote of a rational function, the numerator degree and denominator degree are the same. Therefore, we divide the leading coefficients to find the horizontal asymptote, which would be the infinite limit. It's the limit as n goes to infinity, or x goes to infinity if you turn them all into x's. And that's pretty much all there is to it. If you wanted to use L'Hopital's rule, you could, but nothing would cancel, like I said, because it's n minus 1 squared on the top, n plus 1 squared on the bottom. So just don't try to do anything funny like that. That's pretty much it. I mean, if you wanted to do L'Hopital's rule, you could. You would end up with 2 over 2, which is 1. If you kept going, you'd have to take the derivative twice if you wanted to use L'Hopital's rule. So hopefully that's been helpful, and I'll catch you guys in the next one. Don't forget to check out my 5 math mistakes everyone makes and how to avoid them. Link in the description below. Myers Mathematics. Blessings, y'all.